Hello. My name is CIzmar, and I'm vegan. And I'm also the CEO of Tolgee, and I'm the technical founder. I wrote main part of the backend of the tool, and I'm focusing on development in Kotlin and Spring Boot, and TypeScript and React, which are the technologies Tolgee is written in. But first of all, I need to give you some background before we start with the batch job and queue operation stuff, because I need to show you why we actually need batch operations. So Tolgee is a localization platform where you can manage your localization strings for your app or other software projects. So we have a dashboard where you manage the data. And we also have some cool integrations for modern React or other modern JavaScript frameworks like React. So you can basically translate your strings directly in the app you are developing, which enables you to delegate the localization task to other team members or artificial intelligence. That's cool. But more importantly for today's talk is that Tolgee is self-hosted, and it's also open source. And we want our users to be able to run the whole tool in single Docker command. That means that we don't want to add many services to the stack because we need to keep it simple. And that's why we handle the batch jobs as we handle them. So why do we handle the batch jobs? The first reason is the batch jobs triggered by user. So the users in the platform can basically select some keys, for example, and they can execute some batch operation, like, for example, machine translation. So they can translate their strings in their project using machine translation. And they have to be notified about the progress, which is also an important feature of the batch job processing. So we need to tell them that it's happening and when it's done. So that's the basic use case. In this batch jobs, we don't want to rely on the HTTP request session. We don't want to require the user to wait on, or the client to wait until it's done on the HTTP session. We need to do it on background and just notify the user about the progress via WebSockets, for example. And so the first use case is the batch jobs triggered by the user. The second use case is that we need some repeatable, reliable automations. For example, if something happens in the platform with some translation, we need to run auto-translation to the other languages, for example. Or we need to execute webhooks, or we need to notify the user, for example, via Slack. And we need to do this reliably. We don't want to rely on some in-memory service, or we don't want to rely on some asynchronous process which can break if the node is just disconnected or something like that. So we need to handle the state. And the third case is cron jobs. For example, at some time, we need to invoice our customers. So we need to set the time when the customer is invoiced and run some cron task. And also, we need to have it reliable. We don't want to do that. We don't want, for example, to charge the user twice. That would be pretty bad. So that's the use cases. And then we have some other requirements. We want to have it reliable and stateful and consistent. If, for example, the state of the batch job changes, we need to be sure that also the data which the batch job is handling are changed, and the other way around. If the data changed, then we need to report that the job was successful. We also need to split the large jobs into chunks. We don't want to happen everything in single large transaction. We need to have chunks and run the chunks separately. And we also need to notify the clients about the progress using WebSockets, for example, and we need it universal, which means that we want to have just single one batch job machine for all of these, all of the mentioned use cases. Now the question is, why not to use Kafka or RabbitMQ? Well, first of all, it's additional service. And if we add additional service to the stack, we need to add documentation. We need to tell the users how to run the separate service. And also, if the developers working with separate service, they have to run it somehow, which can add some additional complexity, and it's sometimes harder to test. And also, I'm super scared about handling persistence. I just don't want to store the data more than I need to, because I'm really scared that I'm going to lose customer data. So, and every time I, for example, tried to handle some persistence in Kubernetes, like reliably, it backfired. So I don't like it. I just, for our production, we use some database from Microsoft, and they handle that. And if it breaks, that it's our problem, but that's also their problem. So that's great. So yeah, I'm super scared about that. And also, like, because of like all this data compliances and GDPR, you have to document where you store your data. So if you use like separate service from some cloud provider, then you have to document that you are storing customer data somewhere, and that can be also an issue. If not Kafka or RabbitMQ, then what's the solution, right? In Tolgee, we have basically two options how you can deploy how we can deploy the service. The first option is the Tolgee cloud, where we have like PostgreSQL database as the central point for everything, and we have Redis. So we are managing these two services, but Redis is stateless. We don't care if the Redis dies. We are totally fine with that. We can start it again, and everything runs. And then we have the application nodes. We can have as many of them as we want. It runs in Kubernetes. It gets replicated if we can enable auto-scaling or anything. And each of these nodes are, in the same time, the worker for the batch operations. Then, so everything, all the truth is stored in the database. And we always have the truth stored in database. And if the Redis breaks, we can populate the Redis queue again from the database, and we are completely fine. We don't rely on other state. Also, the thing is that it's consistent. But before we started to implement the batch jobs, we already had the Redis in place. Already the Redis was there. So we didn't have to add another service because of that. We had used the Redis for caching. And then another option how to run Tolgee is, and usually the users who are self-hosting Tolgee are using like single node deployment, where they don't need the Redis for caching. We don't need the additional central point for caching. So the cache runs in memory of the Spring Boot Tolgee app. Also, the queue can be stored in memory, and then the Tolgee app works also as a backend, as the worker, as the WebSocket server, everything you need to run the application. So in both of the cases, we have the same database schema. We have the batch job, which stores the overall information about single job, and then we have the chunk execution, which is the table storing information about each chunk execution. So if the execution fails, we create new row of the chunk execution, and we can retry it. And we can set how many times it's going to be retried. So that's pretty straightforward. For this demo, I created a kind of simplified version because I didn't want to handle the retrying, and because it would be like a bit more complex for the time window we have. So I just removed the chunking and the retrying logic, and let's pretend single job is like single chunk, and we don't need multiple chunks. But most of the principles stay the same. So in our demo, we are going to use Redis for the queue processing, so we can still run multiple nodes. So so we can use Redis for the distributed queue. Redis has this concept of distributed queue, so we can actually like listen for updates in the queue in Redis, and if something is added to the queue, one of the nodes is going to consume that. Now you can say I'm cheating because Redis in our case is actually a message broker. It actually is. So sorry for that, but we are not adding like specific Kafka or RabbitMQ just for managing of the queues. And also for the WebSockets, because we need to notify the users about the stuff which is happening on the nodes, we need the PubSub. We need to notify other nodes when something happens in one node. For example, this node is handling some batch job, but all of these nodes are WebSocket servers. So the client can be connected to any of these nodes. So for example, if client is connected to this node, we need to notify somehow this node to be able to notify the client about the progress change. And that's why we need the PubSub. We need it as a central point for notifying the clients using WebSockets. And to make the whole thing reliable and consistent, we need to be sure that two workers are not handling the same batch job in the same time. And there is this magical SQL flags in PostgreSQL and other databases too. And this is it's this for update skipped locked. This for update flag means that we are locking the row for updates. So if in another query you query the same row for the same row using the skip locked, it's not returned. So we are sure that if we are querying using the skip locked, it's not going to be returned for another worker when some transaction is running elsewhere with the row being locked. And that's awesome thing because we have this central point and we are sure that two workers are not managing the same job in the same time. So we are, for example, not going to charge the same user twice for some usage or something like that. OK, now let's jump to the demo. I have to say that some slides got missing from the presentation, which makes me nervous. But we made it somehow. OK. Yeah, I have some questions. Who is actually, who knows something about Spring Boot? Who is like, who did something in Spring Boot? OK, some of you. Someone who knows the basic concepts like entities, components, and stuff like that. Are you going to get lost or not? Who thinks that get lost? Someone who is getting lost already? OK, one person. So sorry for that. Can you read the text? Probably not, right? We have the presentation mode. OK, now it's better. So we have this job entity, which is basically how we store the job. This is the representation of single row in the database. So we have the ID, we have the job type, we have target, and we have some status. That's pretty easy. But all the magic happens in this job execution service, where we have this run method. And this run method is something we start at the beginning of the application. So when we start the application, we run this run method, and this method runs forever and is handling the jobs. So yeah, we are using the Kotlin coroutines here, but that doesn't matter. It just runs. Imagine it runs like separate thread, and for like specified amount of concurrent jobs, we run like as many as the concurrent jobs threads for working on the for handling the jobs. So forever we are trying to process next job. So and we are running it like in parallel in concurrency count times. it can be 10. So we run 10 separate threads, and each are running forever and checking for new threads, new jobs, and handling them. Okay, so then we have this process next job method, which is pretty important. But yeah, so on the first line, we are taking the next job ID from the job queue. So we call this take method, and now we have to look how this is implemented because it's important. Now we got into job queue component, which has the implementation. And here you can see that the queue is some implementation of blocking queue. And this is important because the blocking queue is concept in Java where we actually, when we call this take method, we are waiting for new element being % in queue, and we just get it when it's when the blocking queue has something to give you, basically. And when there is nothing, the thread is just parked. So we are not consuming any like resources because it can look like this, this while run is going forever and can consume a lot of our CPU. So this doesn't happen because in the method we have this job queue take, and it just waits until there is new item in the queue. And in this queue provider, we basically decide whether we are going to use the Redis queue. So Redis has this distributed queue, so we can use this one, or we can use this queue, this local queue, which is just basic linked block queue from Java. So it stays basically just in memory. I'm using the Redis client, which is pretty nice library for Java for communication with Redis. It works pretty well, and it's pretty nice API, and it supports this advanced Redis function, so I can recommend that. Okay, so let's go back. We have the item from the job queue, so we have the next job ID. And now on the next line, and this is important, we are running the whole job processing in single transaction. So this means that it's consistent. Like when we get the job, we are using this for update skip locked. So we are locking the job using this transaction, and we are sure that other transaction is not to get the same job to process. So this is the code I showed in the presentation. And now we have the job, so we can start processing it. Another thing on the next line is that we have to set save points for the transaction, because the job can fail. And if the job fails, we have to still commit the transaction to store that the job failed. We need to commit the transaction because we need to set the job state in the same transaction. But in the same time, we don't want to modify the data because in the process, something could happen. Like some data could be changed, and then it could fail. So we need to revert it back, roll back to the save point. And then we want to set that the job failed and commit it, which is going to happen this way. Yeah, and so in this process job method, we are just processing the job with the selected processor, which we can dynamically add to the code. Okay, so I wanted to show you some tests. First one is the proof that the job is actually being clocked when we started in one transaction, and that in the second transaction is not acquirable. So what we do in the test is that we launch one thread, we execute one transaction, and we are blocking the transaction until it's done, and we change the done in the second transaction. So we are basically blocking the first transaction until the second is done. And we are checking that in the first transaction, we are going to get the job, and in the second transaction, we are not going to get it. And if I run it, you will see it's going to pass, I hope. It would be Yeah, pretty bad. It wouldn't, but it did. Cool. And the second thing I wanted to show you is how fast it actually is, because it's pretty slow, but it doesn't matter. So we have this testing the throughput, so we can see how many tests we can run per second in the Redis deployment option or without Redis. And if you're gonna search the internet, you will find out that the Kafka can handle 2 million messages per second. So in our case, we can handle, like, without Redis, we can handle almost 3,000 jobs per second. And with Redis, we can do like almost 2,000. But so it's a lot slower. But do we actually care? Because even if we use Kafka, we need to handle the consistency. When we need to somehow store the information about the jobs, because Kafka in this super fast environment probably doesn't do the persistence for us. So it runs in memory. So we have it slower, but it's persistent and consistent. Okay, the last thing I wanted to show you is the reporting with PubSub. It's also pretty simple. We have this job execution service, and here you can see that we are executing this job status report job running when we start the job. Then when the job succeeds, we use this report job successful, and when the job fails, we use this report job failed. And the implementation is pretty simple. We just always call this publish method, and we publish the status to the Redis. And the same way, we can listen for that. I just have test for that. That I just, before each test, I start listening on the topic, and when something happens in the topic, I add the status to the statuses list. So just to verify it actually reports, we can run some tests. But this way, we can manage the central point. So all our nodes will know about the changes or events happening in another node, and then we can implement our WebSocket logic to actually notify the users about the events. So I hope it was understandable. I just tried to show the basic concepts, and I think this might be it from me. If you would like to look in the repository, you can use this QR code, or you can go to this repository, or if you would like to connect with me on LinkedIn, there is this another QR code. So that's it from me. Do you have some questions? Question. Nice. Well, at the beginning, I tried. Maybe I should repeat the question. Very nice. OK, the question is if it was natural that we came up with this, or if we had this requirement to not add another service. Is it correct? OK, so I tried at the beginning to use RabbitMQ because I had some experience with that. And I wanted to do the testing, and when I added the service, suddenly I had to start the container for tests, and the container was starting about like 7 seconds. And I was like, OK, I don't want to start this container every time I'm starting the tests. And then when I was thinking about that, I realized that actually we don't need that because we still need to handle most of the stuff anyway. So, so that was the basic story, yeah. Any question? Now I should repeat the question, but I don't think I completely understood. Okay. And the question is if we know what is the job gonna do, or and you mean in the code? You mean, so do you want me to show the code? Okay. Okay. So we have this in the, I didn't show it, but in the job, that's actually a good question because I didn't show it. Because I didn't think it's important, but probably it is. Yeah, we have this. So what we do is that we have like some interface, which is this job processor interface where we have some type, and in our job execution service, we basically require all the job processors, so all the beans, all the components which implement this interface, and then we just create a map from them based by type. So we have the map of the type to processor, and then when we are processing something, we search for the processor by the type. So we have some also some examples how the processor can look like. We have, this is just examples, but we have this, for example, this greeting job processor, which just logs something, then sleeps, and then logs greeting, and then it tells you that greeting is done. But normally you can add whatever you want in this logic, basically. So as you said, it can update something, delete something, or anything. Via this target, the job. When you are creating the job, you basically store this entity with some target, and it's generic. So you can usually, like in our implementation, we put there, for example, list of key IDs, so we know which keys are going to be managed by the job, and we also have some parameters field. So we add some parameters, like, for example, which languages we are want to translate to. And then we have everything we need to process the data. Please.
You were talking about you were using routines, but also that the work is doing in parallel. I didn't catch where exactly do you specify that you want to really what you really want to do is spawn a thread or a process to
Yeah. So it happens here that we are launching basically new background job which does this global scope launch, and here for the concurrency, which means like we are this repeat method means that we are executing this thing multiple times in Kotlin, and then here we have another launch. So this means that this many threads will be spawned somewhere in the background. It's not the best possible implementation. It just
so you have like the concurrencies. You have multiple queues.
No, we have just single queue. We are just taking the data or pulling the data from single queue.
Yes, but you have like each dispatcher is like a parallel queue on itself. It takes from the queue in parallel.
Yes, yes. And I'm out of time, so thank you.